Imagine traveling on the ground but moving faster than a Cessna aircraft flying at full throttle. You look out the window and the landscape is nothing but a blur of green and gray. On April 21, 2015, on a test track in Yamanashi, Japan, a train shattered our understanding of ground transport. It didn't just break a record, it obliterated it. The speedometer hit 603 kilometers per hour. That is 375 miles per hour. This isn't science fiction. It is the SCMaglev, the L0 Series. It is the fastest train ever built. But the most surprising thing isn't just how fast it goes. It's that to reach these speeds, it had to stop being a train entirely. Today, we're looking at the engineering miracle that learned how to fly on the ground. Right here in Simple Things Surprising Histories. To understand why the SCMaglev exists, we first have to look at the problem with traditional trains. Japan invented the modern high-speed railway in 1964 with the Shinkansen, or bullet train. It was a marvel. But engineers quickly discovered a wall they couldn't break: friction. When you run steel wheels on steel rails at extreme speeds, physics fights back. The vibration becomes dangerous, the noise becomes deafening, and the wear and tear on the tracks is immense. Engineers realized that if they wanted to go faster than 350 or 400 kilometers per hour, they couldn't just build a better engine. They needed to eliminate the track contact altogether. They needed magnetic levitation, or maglev. Now, maglevs have existed before, like the Transrapid in Shanghai, but Japanese engineers wanted to go faster and safer than anyone else. They developed a unique technology called superconducting magnetic levitation, or SCMaglev. So how does it work? The SC stands for superconducting. Inside the train, there are magnets cooled by liquid helium and nitrogen to temperatures approaching absolute zero, about -269 degrees Celsius. At this temperature, electrical resistance disappears, creating magnetic fields that are incredibly powerful and efficient. These magnets interact with coils inside a U-shaped concrete track. But here is the fascinating twist that separates the SCMaglev from other magnetic trains. It has wheels. Unlike other maglevs that float from the very start, the SCMaglev drives like a normal train, on rubber tires until it reaches about 150 kilometers per hour, 93 miles per hour. Only then, once the magnetic force is strong enough, do the wheels retract like the landing gear of an airplane. The train lifts 10 centimeters, about 4 inches, into the air. It is literally flying, held in the center of the concrete channel by invisible magnetic walls. Because there is no friction, the only thing slowing it down is the air itself. This technology is currently being built into the Chuo Shinkansen line. The goal is to connect Tokyo to Nagoya and eventually Osaka. But traveling at 600 kilometers per hour requires a track that is almost perfectly straight. You can't take sharp turns at that speed. Because Japan is mountainous, this led to an incredible engineering decision. 86% of the track is underground. When this line opens, it will shrink the country. The trip from Tokyo to Nagoya, which currently takes 90 minutes, will be cut to just 40 minutes. It essentially turns two massive cities into a single commuter zone. It creates a megalopolis of over 60 million people, connected by a vehicle that floats on a cushion of physics. The SCMaglev is more than just a fast train. It's a reminder that sometimes the only way to move forward is to rethink the very basics of how we move. By removing friction, we didn't just gain speed, we gained a glimpse into the future of human connection. If you enjoyed this flight through history and engineering, please hit that like button. It really helps the channel. What simple thing with a surprising history should we cover next? Let me know in the comments below. Thanks for watching.